Hi, I'm Jay Schultz of Pool Technicians. We built a test tank to do a comparison and a performance testing between a standard single-speed induction type motor. These are the type pumps that we've used in this industry that I've been in for 30 plus years, versus one of the new variable speed pumps with a variable frequency drive motor. The motors in these pumps are permanent magnetic motors, the type used in hybrid cars. Source power pump here, that's just a standard single speed. We're going to turn it on, see how much it's pumping, and see how much electricity it's using. The pump running, we're pumping right about 80 gallons a minute. Pressure against the pump, this you would read on your filter, is right about 13 psi. Cost to run that 80 gallons a minute on that pump is right about 2,000 watts or 2 kilowatts. 2 kilowatts, what's called a kilowatt hour. If you look at your electric bill, it's written up in kilowatt hours used. Edison says they use the number of about 25 cents a kilowatt hour. This pump is using 2.0 kilowatt hours or 2,000 watts. The cost of that is about 25 cents per kilowatt hour. So if this is 2 of them, the cost to run this pump is approximately 50 cents an hour. If you have a pump like this and you're running the pump 8 hours a day, that's approximately $4 a day that you're paying in electricity to run your pool. When you multiply that times 365 days a year, you probably come up somewhere $1,300, $1,400, some plus dollars a year in electricity just to circulate your pool pump. Okay, let's see what the new variable frequency drive pump is going to do without any performance loss and pumping the same 80 gallons per minute. Oh. Okay. Get her up to 80 gallons a minute. So again, flow meter's about the same. We've got about 12, 13 psi here. It should be the same. Now, how much electricity are we drawing without sacrificing anything? 1.66, 1,660 watts. So we're saving 340 watts just because this type motor is more efficient. But where the real savings come in is when we start throttling the motor down. We went from 80 gallons a minute, now we drop it to 60 gallons a minute. We drop our pressure a little bit more. We're pumping right now 3/4 the amount of water that we were pumping originally. But how much were we pumping it for? Now if you notice, 0.82, 0.81, 810 to 820 watts. Only giving up 25% of performance and flow. We're using a lot less electricity. Here's where the numbers will make more sense. Let's cut the flow down to 40 gallons a minute. 40 gallons a minute is half of 80 gallons a minute. So we're pumping half the amount of water. So the theory behind this is we can run this pump twice as long, pumping it half as fast. So at 40 gallons a minute, if you also notice we have less pressure, our kilowatt meter is down to 0.29. That's 290 watts. We started at 2,000 watts on this older pump. We're now down to 290 watts. If we run this pump twice as long at 290 watts, we can pump the same amount of water for 580 watts that it took 2,000 watts to pump with here. So this is where getting a 50 to 70% savings is very doable and very easy with these pumps, just by cutting the speed down and running them more hours. If we cut down to one last lower speed, we're at about 20 gallons per minute right now. If you notice at 20 gallons per minute, I don't know if you can hear the pump running or not, but they just get so quiet and they just get so efficient that they just hardly make any noise at all. Now at 20 gallons a minute on our meter, 0.07. That's 70 watts. We went from 2,000 watts to 70 watts. We can run this pump pumping 20 gallons a minute, 24 hours a day. We can run it 24 hours non-stop for about the same money it costs to run this pump 1 hour. Here again, this is where the big savings on these pumps come in.